So in our last section, we learned about the secant line, right? So on last Monday night, we learned about the secant line. And in this section, we'll actually learn about tangent line, okay? And the tangent line is a line that touches a curve at exactly one point, okay? So you'll see up here in this diagram that I've put in the left-hand side, our secant line touches at two places, and our tangent line only touches in one location, okay? And when we use the circle, we can see the difference between those two, right? So the one thing I will say about our tangent line is it really is just the slope, right? So we could talk about that in terms of slope. And so if you think about that, we have, I'm going to zoom that back out a little bit, that our slope is equal to our limit as h approaches 0 of this quotient difference. Okay, so the limit is also the instantaneous rate of change for our function at x. And so that's kind of what this is showing us over here, is that at any specific instant, right? So if I'm looking at this point here, Q5, you could see that my tangent is here. But if I'm looking at Q4, then my tangent would be that line. Q3 would be that line, Q2, Q1, right? And those are all different, and so they'll only intersect that graph in the one location, okay? Any questions so far? So this right here, you can look further if you want to look at it in the textbook. That is on page 139 in your textbook. Okay. So let's look at and talk about some examples. It is going to be important that you are able to do derivatives using this method because it will be required on the exam, right? So in a little bit tonight, you're going to learn a shortcut for doing derivatives, but you will be required to do it this way for one problem on the exam. So make sure that you're comfortable with it, because if you just do the shortcut method, you will get no credit on the exam, okay? So for this problem, well, when we're looking at this, for a function where we have y equals sum f of x, its derivative at x is defined by the function f prime, right? So I'm going to come back over here where we have blank paper. So we can say f prime of x, that is derivative. Okay, that derivative is equal to the limit as h approaches 0 of our quotient function. Okay, and that is providing that a limit actually exists, right? If f prime exists, then we say that f is differentiable at x, okay? And so when we move over here to this page, we can actually look at an example. So the first thing that we are asked to do is to graph the function negative 2x squared, okay? So if x is equal to 0, that's going to be negative 2 times 0, so that's 0. If x is positive 1, then that's 1 squared times negative 2, so that's negative 2. If y is, or if x is 2, then that's going to be 2 squared is 4 times negative 2 is going to be 8. So that's 2, 3, 4, 5, 6, 7, 8. Because this is a parent function is a parabola, we know that it is also true for the negative x's. So this graph looks something like this, and these will go on to infinity. Okay. So that's part one. It asked us to graph it. Now it wants us to draw the tangent lines at our x coordinates is -2, 0, and 1. So we're just going to blow this up over here. Let's go ahead and I'm going to just get a straight line. And so it said it wanted us to draw our tangent line to the graph at x equal to -2. So that's this one right here. So we are going to touch the graph only in that one spot. We'll have it, if this was our spot right there, it's just touching our graph in that one location. Similarly, so it'll be a lot easier to write these out on the computer where you're picking from a graph or whatever in your homeworks. You won't have to draw this out on an exam. You'll just have to do the part C here in a minute. So a tangent line to 0 is going to be here. And our tangent line to +1, let me actually just put, so you can see our graph doesn't actually, let me, okay. So something a little more like that. And so it would be something like that, okay? All right. So the green there then is our tangent line. So part A, we did the graph in blue. Part B, we did the tangent lines in green. And now we want to determine what is this limit here. So let's go ahead and do that in the red. And so for that one, we are, remember, just substituting f of x plus h first. So we have that our limit as x approaches h of this f of x plus h minus f of x over h, that really translates to the limit. So actually, instead of writing the limit first, let's just do that portion. So I don't have to rewrite that wording, the limit h approaches 0, every single time we do a equal sign. So this would give me -2 x plus h squared minus -2 x squared. Okay. All of that divided by h. Okay, we want to simplify this. So we have -2 x plus h times x plus h gives me x squared plus 2xh plus h squared. And then we'll just distribute this minus to both to this negative here. And this is going to give me minus times negative times negative is positive. So that's going to be 2x squared, all of that over h. Okay. So the next thing we want to do is we want to distribute this -2 out here to all those terms. And that's going to give us a -2x squared minus 4xh minus 2h squared plus 2x squared divided by our h. Okay. Now we can see that we have a positive x squared and positive 2x squared and a negative 2x squared. We can also see that in our numerator, both terms have an h in it. So let's go ahead and factor an h out of both terms. So if I factor an h out of the negative 4xh, it's going to leave me with the negative 4x. And if I factor an h out of the negative 2h squared, it's going to leave me with 2h. All of that divided by h. I have an h in my numerator and an h in my denominator, so I can cancel those out. And it leaves me with negative 4x minus 2h. Okay? Now, remember, we're not done. Now, what we have to do is we have to actually take the limit of that. Okay? Based on the things and the techniques that we learned last class period. Okay? So when I go to take the limit of that, so I have my limit as h approaches 0 of negative 4x minus 2h. That really is equal to negative 4x minus 2 times 0 because h is approaching 0. And so that is negative 4x. Okay, so our limit of that function is negative 4x. Okay, question. So the last step that we have here then is the last step that we have here is it wants us to find f prime. Remember, that means the derivative, which is what this is right here, right? It wants us to find it evaluated at -2. So evaluate this at -2, evaluate it at 0, and evaluate it at 1. Okay. So for that part, we say f of -2, right? F prime of -2 is equal to -4 times -2, which is +8. Okay. F prime evaluated at 0 is -4 times 0 equals 0. And F prime at 1 equals -4 times 1, which is -4. Okay. So on the exam, you guys will have to do a problem that is similar to this portion right here. You'll have to do the long work. So this is what we consider the long way. In the next section, 2.5, I will be able to teach you a lot of other rules that help us to get that much quicker than evaluating it the long way. Okay, questions?
You said on the test we will still have to do it the long way though, right?
For one problem, and then all of the other ones you can do it the short way.
Thank you.
I did have just a quick question. So you inserted 0 because of the limit of h is 0?
Yeah.
So if it was any other number, that's what we would, insert that with as well, correct?
You would in other things, but when
Mhm.
you're talking about the difference quotient, it's always as h approaches 0.
Okay, thank you.
Wait, I came in like a little late. What is the shorter way of doing this?
We haven't learned it yet.
Oh,
Next section. I'm just prefacing because we're getting the lecture, both of them in one night. I really just want to foot stomp that you have to know how to do it this way, because in about 20 minutes, you're going to learn a much faster way, but you still have to do this for the exam at least once. Okay. All right. So let's look at some more examples. This is like problem number 22. And these problems are in your textbook on page 144. And so for this section, it's number 22. It says it wants you to find an equation of the tangent line to the graph of this function f of x equals 4 minus x squared at each of those points. Okay, so we're not going to do the workout on all of these. We'll do the first one, part A. Then I'll tell you what the answers are to part B and C so that you guys can practice those on your own and see if you have any problems coming up with the technique or with the solution after we've just worked through it. Okay. So the first thing that we need to do is find f prime of x, right? So the first thing we want to do is this f prime of x, which remember, to do that, we need to know what f of x plus h minus f of x divided by h is, right? And so that is, and then take the limit of that, right? So first, we need to substitute x plus h into our equation. So that is 4 minus, we have this 4 minus x squared. So 4 minus x plus h squared minus 4 minus x squared divided by h. Okay. And so this will be 4 minus x squared plus 2xh plus h squared minus 4 plus x squared over h. Okay, simplify this down some, and we get 4 minus x squared minus 2xh minus h squared minus 4 plus x squared. All of that divided by the h. Okay. Now we can see that we have a negative 4 and a positive 4. We have a negative x squared, a positive x squared. So those are going to cancel out with each other. And we could see that both of our terms that we have left have an h. So we'll factor an h out of both terms. And that gives me h times negative 2x minus h divided by h. And so we have an h in the numerator and h in the denominator. And so this simplifies to negative 2x minus h. So now what we want to do is let's take the derivative of that. All right. And so that is the equivalent to the limit as h approaches 0 of this negative 2x minus h. Okay, so that is negative 2x minus 0, which is just negative 2x. Okay, so that's our derivative. Okay, now it wants us, remember part A asked us to find f prime at 1. Well, we have to find f prime at 1 first, because Oh, actually, it's at -1. Okay. So f prime of -1 is going to give me -2 times -1, right? Because we're doing it based off of this. And so that equals +2. So that tells me that the slope of the line tangent to that curve at that point, -1, 3 is 2. Okay, so let me write that here just for you guys to process. Okay, so that's telling me that the slope of the line tangent to the curve at that point, -1, 3 is 2. Okay. So now, so that is slope equals 2. Okay. So now we need to substitute the point and the slope into the point slope equation. Okay. Point slope equation, I'm going to give you that. Point slope this is us digging back to our algebra days to get that. But our point slope equation is y minus y1 equals m times x minus x1. Okay. So that's our point slope equation. And we just need to substitute in the things that we have, right? So it gave us this point. So this is x1, this is y1, and this is m. Okay, so we plug those things in here. And so we have y minus y1 was 3. Slope is 2 times x minus my x1, which is -1. Okay, so we simplify that. Y minus 3 equals 2x. This is +1, so this is +2. Move the add 3 to both sides, and we get y equals 2x plus 5. So this is the equation. This is the equation of the tangent line. Okay, so we were able to find the slope, and then based on the slope, we were able to use the point that we were given along with the slope and the slope point slope equation to determine the slope of that tangent line. Okay. Questions? All right, so I'm going to just come back up here and I will tell you that for part B, right, for this one, our slope is going to equal 0 and our equation will be y equals 4. And for this one, our slope is going to equal -10 and our equation is going to be -10x plus 29. Okay, so during break or this evening or whatever, tonight, before next class, whatever, before you work your homeworks, it might be beneficial to try and work through those, see if you get the same answer, just to have that little bit of practice. Okay, questions?
Do we have time to do one more like this one?
We can come back to it at the end of class if there's time, for sure. Yeah.
Okay.
We can do one of these other two. So just stay on after class, and just remind me that it's out of slide deck 1.4, slide 3.
Okay, thank you.
Uh-huh. All right, so this next type of problem is where we, coming off of page 144, question number 26. Well, there's 25 through 30 like this to practice from. But so for this one, it wants to list all x values for which the function is not differentiable. Okay, so when we want to look at this, we want to determine the function where it's not differentiable, because it's either a corner or it's discontinuous. Because to be differentiable, remember, we want to be kind of a smooth, continuous kind of curve. So if we have a corner, which means it's a sharp change in direction, or if we are discontinuous, like there's a break in the graph or something like that, then we're also not going to be differentiable. Okay. So for this problem, I'm going to just put a box around things that are like a corner, and we'll circle the things. So if we put a box around, I'll do it on the numbers at the bottom, where something's a corner, and then a circle around things that are discontinuous. Those will get at the things that are not differentiable. Okay. So first of all, let's start with the corner. So as we're coming around here, you can see I come up and I make a sharp change. So this right here is a corner. So x2 would not be differentiable because it's that corner, right? So again, it's a sharp change in directions. Okay. Similarly, number 5 is also, right, we're going up and then we are changing our direction rather quickly. So 5 is also not going to be differentiable. Okay. All right. So we also, so 2 and 5 are not differentiable because they're corners. And to be discontinuous, it's basically where the graph is not smooth. So it may be that, I'm gonna go ahead and make these a different color. So as we're coming, first of all, if it's got a hollow dot, that's easy. That tells me there's a jump in the graph. That's hollow. It's not differentiable there. The graph, you can see there's a jump in the graph here, right? So it's not differentiable. Here, this is a smooth through that thing. So this one's going to be differentiable, right? When we come to this graph over here, 3, it's kind of a smooth. Yeah, it changes direction, but it changes direction in a nice, smooth manner. It doesn't, you're not going in one direction and a change to the next. When we get to this one, we're hollow. So actually, I said I was going to put a circle around them. So 4 is going to be discontinuous, and you'll see that by that hollow point on the graph. This one, we're coming down here, and then we kind of go, so it's not continuous, because we're coming in this direction, and then we change directions, right? It's hard to see in that graph, though. For number 7, this one, look, we're coming up here, but then we change directions. So it's really hard to see, but we're changing directions. It would be easier if it was coming like this and you could see. But we'll see later on, as we go through this part of the course, you'll see that that's also not going to be differentiable, because we have what we're going to learn at some point in the class is there's an inflection point there. Okay. And then this one is continuous as it is a smooth transition, okay? So we really want to just make sure that there's not a change, an abrupt change in direction in the graph, well, technically, I guess that would be good even for these corners, right? Because your abrupt change in the direction of your graph. Then you want to make sure that it's smooth and continuous as well, okay? Questions?
So to properly answer the question, we would list all of the ones that you put either a circle or square around.
Yes. Okay. All right. So this next problem, I do want to tell you, this one is a little bit crazy because we have to do the difference quotient to simplify this down for the limit. So there'll be lots of steps, and I chose this one because I won't give you one like this on an exam for sure, but I wanted to walk through one of the really complex ones so that when you get to the homework, if you have one similar to this, that you have an example to walk through with, okay? And then also the textbook or the online, the homework, a lot of the problems have at the bottom, you'll see like, ask your professor or help me solve or show me an example, right? Down at the bottom. And so for the help me solve, it's going to help you step by step through that exact problem that you're seeing. But then it's going to make you do another one to get credit for homework. If you say, show me a similar one, it'll step you through a similar one, and then you can continue working on the one that you were assigned. Okay? Question.
I did want to ask, why does some of the questions show that it can help you solve the problem, but then others don't?
I don't know. It's not something that I can control. It's what Pearson and my math lab has made available. Because I gave you guys visibility of all the ones that they have help for.
Okay, thank you.
So, yeah, I don't know why they don't do it for all of them and they just do it for some of them. I really don't know. So if there's one that does not have the help me solve this or show me an example, please feel free to click the ask my instructor button. It'll send me an email. I'd ask that you follow it up with a picture of your work so I can see where you went wrong or where it is you got stuck and help you go from there, right? So I don't want you to just go through and say, how do I solve? How do I solve? How do I solve? Because I'm not going to answer unless you show me where you've at least attempted it and haven't been able to get it solved. Okay. So, but I'm happy to do that and work through those with you, so long as you've actually put forth the effort as well. Okay. All right. So let's look at this one. So this one, the textbook tells us it wants us to find f prime of 1 over the square root of x. It tells us to see example 74 in section 1.3 for this, okay? So that is on page, I didn't write the page down. Let me pull that up real quick. Oh yeah, problem number 74 out of this section is on well, I don't know. Maybe I wrote that down wrong. Number 50. It says exercise 74 in section 1.3, but there is no exercise 74. So
You have to go to all the way at the end of it to the little like practice section, and there it will give you what you're supposed to see.
yeah. So I actually wrote it all out in my notes for you guys. So in this one it says, first of all, we want to figure out what is our f of x plus h, right? F of x plus h is 1 over the square root of x plus h, okay? So that means that when we're trying to do our f of x plus h minus f of x over h, that's really just 1 over the square root of x plus h minus 1 over the square root of x divided by h, okay? We want to get a common denominator for our numerator. So getting a common denominator is going to give me 1 over square root of x plus h times square root of x over square root of x minus 1 over the square root of x times 1 over, square root of x plus h over square root of x plus h. Okay, so that's just getting our common denominator there. Okay, when we do that, that's still over h. So when we get that common denominator, it's going to give me the square root of x, because 1 times square root of x is square root of x. And this is square root of x plus h minus square root of x plus h over square root of x plus h. All of that divided by h. Okay? So we can put that all under one roof. So we have square root of x minus square root of x plus h over the square root of x times square root of x plus h divided by our denominator of h. Remember in math that dividing by something is the same as multiplying by the reciprocal. So this is the same as x minus square root of x plus h over square root of x plus h times, so it would be like divided by h, but remember that's the same as multiplying by the reciprocal, so that's times 1 over h. Okay, any questions about that? Okay, so that gives me the square root of x minus square root of x plus h divided by h square root of x plus h. All I did was move that h up under the denominator. Okay, now let's rationalize the numerator. Okay, so let's rationalize. So what does it mean to rationalize the numerator? So in this case, I'm going to multiply by the opposite sign here. So to rationalize that numerator, I'm going to scoot this out of the way a minute. Okay, so to rationalize that denominator, I'm going to multiply by the square root of x plus, right, the square root of x plus h. But whatever we do to the top, we have to do to the bottom. And it's like we're just multiplying by 1, because anything divided by itself is 1. Okay? So this is going to give me square root of x times square root of x gives me x minus So when I multiply it by this, I get a minus square root of x plus h. When I multiply this one, right, doing our FOIL, I get the positive, so those go away. And then I just multiply these two by each other, so I get a negative. I'm going to get a negative x plus h, because the square root times the square root makes the square root go away. All of that divided by our h, square root of x plus h. Now we have to times it by the square root of x plus the square root of x plus h. That's the denominator here. Okay. So now I distribute this negative to both pieces. So that's going to give me x minus h. So those are going to go away. And so that's going to give me, I'm going to just, our denominator is going to stay the same. But our numerator is going to be just this negative h. Okay. But I have an h in both my numerator and my denominator. So that is going to give me -1 in my numerator. And we take the h away from the denominator here. Okay. So that right there is what my x is, or my f of x plus h minus f of x divided by h is equal to. So now we have to take the limit of that. So the limit as h approaches 0 of all of this okay, of all of that is going to be, so we plug in a 0 for all of the h's. So that is -1 over square root of x over x plus 0 times square root of x plus square root of x plus 0. Okay? And we can simplify that to give me -1 over square root of x times square root of x plus square root of x. Okay? So that simplifies to an x squared times an x squared, or the square root of x times the square root of x gives me x, and square root of x plus square root of x gives me 2 square roots of x. And so we can just put that all together as 2x square roots of x. So the limit of 1 over the square root of x is all of this, okay? And so it took all this work, right, to get down to that. Next section, we'll learn how to get to this in just like a couple of step process. Okay? But again, you'll have to work through a problem not nearly as complex as this one on the exam. So it's important that you understand how to do the process. Questions? Right. So we're going to take our first break. right? And I'm going to leave this problem up here. What I'd like you to do is, if you feel like working through it, what I would like you to do is work through this problem using the x plus h minus f of x over h, and see if you can come up with what is the derivative of this using the long way, okay? Now, I will tell you that to save you a little time, x plus h to the fifth is, let me just move that right here. I will tell you, so you don't, because that could take you the most amount of time, is x to the fifth plus 5x to the 4h plus 10x cubed h squared plus 10x to the 2h cubed plus 5x h to the 4 plus h to the 5. Okay, so I'll give you that, and then you guys take a little bit of time. We'll take a 10-minute break, but round up to 7:50. So let's come back at 8 p.m. and we'll look at this problem here, and then we'll move right into section 1.5. Okay. All right, it is 8 o'clock, so let's go ahead and keep going. Jasmine, you're unmuted. Did you have a question?
No, I'm sorry.
Nope, you're good. Was anybody able to come up with what the derivative is here for this one? Did anyone take the time to try it?
I tried, but I got stuck on the middle of it.
Okay, yeah, and that's why, again, this is a x to the 5. Your exam will probably just be like something with the x squared involved, so it doesn't have that level of complexity. But let me go ahead and do this one for you just real quickly so that you have it as another example to look through with your homework. So we have this one as x plus h to the 5 minus x to the 5 over h. So this is just our f of x plus h minus f of x over h, okay? And so that equals, it's going to equal all of this. I'm not going to write that again. We'll make this green. So it's going to be all of that, right? This is the x plus h to the 5th power minus our x to the 5th power. All of that divided by h. Because this is positive, I can actually drop these parens, right? Let's do that. And then I will see that I have a negative x to the 5 and a positive x to the 5. I also can factor out, let me just paste this again. Change it to green. The only thing I'm doing is I'm going to minus off that x to the 5 that I have out there. And so we have all of that divided by our h. And what I'm going to do is we're going to factor 1h out of every single one of these terms, okay? So what that means is this goes away, so we're going to bring the h out here, right? So that h becomes a 0, this h becomes a 1, this h becomes a 2, a 3, and a 4 because we factored that out, okay? So that we can cancel the h in the numerator and the h in the denominator. Okay? So that's going to leave me with my limit as h approaches 0 of 5x to the 4 plus 10x cubed h plus 10x squared h squared plus 5x h cubed plus h to the 4. Okay? So when we plug in 0 for all of that, that's going to give me 5x to the 4 plus, I'm going to just copy all of this that has h's. And for every h, we're just going to replace it with that 0. And that simplifies to 5x to the 4. Okay? Question. All right. So that concludes this section. We are going to revisit this in the next section, this one problem here particularly. So just keep in mind, take note, x to the 5th power. We're going to do that in the shortcut way. Probably take one line of writing to get to the answer when I reveal the the different rules, the power rule for doing derivatives, okay? All right, any questions before we move on to the next section? All right, so here we have it, the power rule. So as I mentioned, what we have is the power rule tells us that if you have some number k, that's to the exponent, right? If we have y equals x to some value k, then the derivative, or this d over dx, that's what you can signify derivative as well. And so basically what that does is you just take this k, you take the k from right here, you bring it in front, and then you just minus 1 off of the k, okay? So when we're looking at x to the 8th power, right? So when we're looking at that, then we end up with dy dx. It's the same as saying y prime, okay, is equal to, well, in this case, my k is equal to 8. So this is going to be equal to k, which is 8, times x, k minus 1. So my derivative is equal to 8x to the 7. Okay? So let's go ahead and revisit then this problem, right? So we had f of x is equal to x to the 5. If I want to know what the derivative of this is, that is my k is equal to 5. So my derivative, or y prime, is equal to 5 times x, 5 minus 1. So my derivative is 5x to the 4, which is exactly what we came up with, right? So again, on the exam, you will have one problem that you have to work through like this. The rest of the problems, you can use the power rule or any of these other techniques that I'm going to show you between now and our first exam to work through those problems. You'll just have to, again, like I said, there will be one, and I'll tell you on it exactly what you need to which one it is, right? You won't have to guess or wonder or anything like that. It'll say you must use this quotient difference for this problem. Okay? All right. Any questions so far?
So my question is that so all the exponents are going to be k, correct?
Say that one more time.
The exponents are the ones that represents k on the power rule? Okay.
On the power rule, yes.
Okay, thank you.
You're welcome. All right, so now we have a new theorem, another one. This is the constant rule, okay? So if I want to take the derivative of a constant, the derivative of a constant is always equal to 0, okay? And here's why. Think of it like this. This is really the same as y equals 7x to the 0, right? If you think of it, 0 times x gives me 0, right? So that would be 7 times 0, and then x to the negative 1, that equals 0, x to the negative 1, it equals 0. Okay? So the derivative of a constant is always equal to 0. Question. Okay. Our next theorem is the constant times the derivative theorem, okay? So the constant, if you have a constant times some function, that's kind of what I did in that previous one, even though just to show you the zero. But essentially, this is the same as saying, if I wanted to take the derivative of some constant 3x to the negative 5, right? That's the same as I can pull this constant into the front. So that's the same as saying 3 and then taking the derivative of the remaining, right? And so that would give me 3 times this negative 5, right? Because k equals negative 5. And then x, negative 5 minus 1. So negative 5 times 3 gives me negative 15. X raised to the negative 5 minus 1 is negative 6. Okay, questions? So now we're going to move into what's called the sum difference rule. And so what that's telling me is if I have two functions, if I want to take the derivative of function f plus function g, that's the same as the derivative of function f plus the derivative of function g. And it's the same if you're minusing off as well. Okay. So here we have 1, 2, 3, 4 functions. So this is like function A plus function B plus function C plus function D. And we can do that just the same. Okay. So in this case, we have let me add a 3 here. My notes has a 3 there. All right. So if we had a problem like this, then we would say if we wanted to, first of all, you don't have a rule yet for how to deal with something in the denominator. So let's go ahead and we'll rewrite this as 8x to the negative 3. Just a quick little refresher on exponents. If I had x squared over x, right? Let's just say x to the 5. Okay. I can bring this up to the numerator. When you do that, you just change the sign of the exponent. So it becomes x squared times x to the negative 5. You just move the exponent up. Okay, change the sign. Then, because I have two exponents multiplied by each other, that's the same as x2. I just add them together. So that's going to give me x to the negative 3. Okay. So if I wanted to get that back, that's also the same as 1 over x to the positive 3. Okay. So if you need a refresher, Khan Academy does great little videos and stuff. So you might want to check them out. KhanAcademy.com. They're free resource. I would just in a Google search, just put Khan Academy exponents or something like that, or any topic that you're interested in learning through Khan Academy. But we've already probably spent more time than we should have on exponents just because that's something that you get out of like pre-algebra. All right. So now that we kind of know how to treat these exponents, we can move on. So now if I want to take the derivative, right? So I could do y prime or I could do dy dx, dy over dx, it's okay too. I tend to write just y prime most of the time because it's quicker shorthand. All right. So we have here then that is really dy dx, right, of this whole thing that we have here, which is our 3x to the negative 2/3 plus x 3/4 plus x 6/5 plus 8x to the negative 3. Okay. So when we're looking at that, we can actually break that out as the derivative of 3x to the negative 2/3 plus the derivative of x to the 3/4 plus the derivative of x to the 6/5 plus the derivative of 8x to the negative 3. Okay, so this is using that sum difference rule. Now, these constants we can pull out into the front. Okay, and so that's going to give us then 3 times, now we're going to have the derivative of x minus x to the negative 2/3. So we bring that negative 2/3 because that's our k. And then this is x. We have negative 2/3 minus 1. 1 is the same as 3/3. That gives us a common denominator. It'll make our math a little bit easier in a moment. Okay, do the same. We have plus 3/4 x. We have 3/4 minus 4/4 plus 6/5 x, and then we have 6/5 minus 5/5 plus 8 times negative 3 x to the negative 3 minus 1. Any questions so far? Okay. So this is going to, there we go, give us, the 3's cancel here, right? And, let's get blue back. So that gives me negative 2 x to the negative 5/3 plus 3/4 x to the negative 1/4 plus 6/5 x to the 1/5 minus 24 x to the negative 4. And because this one here on the end, because this started out as this fraction, let's go ahead and move this back down into the denominator. And when we do that, I'm going to just copy this portion. When we bring that back down, we have minus 24 over x. Change the sign, it becomes positive 4. Okay. Questions?
For the other exponents that are negative, why don't we turn those into the same way we did the last one?
We could. I was just saying we're following the lead. See how this one started with the negative here? I would say it's always most proper to have positive exponents. So in that case, I'm just saying my math lab would accept this, but it would be more proper to make this as x over 5/3 and this one would be plus 3 over 4 x to the 1/4. Okay. Now,
And
go ahead.
I'm sorry. So either way is technically correct,
Correct.
but this way is like the proper way, so they're all positive.
And it's even a little bit more proper, right? If you think about this, right? X, the square root of x is the same as x to the 1/2, right? This is
Yes.
telling me this is what goes on the x, and this is telling me what kind of root it is, okay? So that being said, it's even more proper, right? I need to scoot these up for a little more space, to say this would be -2 over the top one is the value with the x. So we have x to the 5 over the cubed root. That's the most proper way that you would write this piece right here. But then again, it's not proper to have, those radicals in the denominator. So at what point does it just become ridiculous, right? Because it's always most proper to not have a radical in the denominator. But this one would have also been like 3 over 4 x to the 4th root, and so on. Does that make sense?
Yes.
It's a 1 5th root of x. Okay. So, but your textbook would have, or my math lab would have accepted this. It would have also accepted that, right? It may have even accepted this. I don't know. Okay. Question.
Thank you.
All right. So this next problem, page 155 in your textbook, it asks us to find the equation of a line tangent to the graph. Okay. And so, like the previous section, we'll just look at let's look at the first one, and then actually, since the first one is 1, 0, let's look at the second one, and then I'll tell you what the other two parts are. Okay. So for this problem, we first have to find the derivative, right? So the derivative of our function is equal to d over dx of this x cubed minus 2x plus 1. Okay. I'll do this one more round where I write it all out, but honestly, we could probably get in the habit of not writing it out in broken form, where we're saying d dx of x cubed minus d dx of 2x plus d dx of 1. Okay. So when we look at that, we could say, okay, so this is 3x squared minus 2 plus 0. Okay. So that means my derivative is 3x squared minus 2. But I feel like you guys are all, probably able to just look at this and go, oh, that's the x cubed. So I'm bringing the 3 to the front and decrementing that one. So that's 3x squared. Right? I don't think you have to write it out like this to then be able to do this. So that is one step like we're doing this right now just to help you guys visualize it, but that step right there will not be required on an exam. You could just straight give me that for something as basic as this is, right? We'll get into more complicated things where you have to write things down and you have to show steps. But for this one, I think that I will trust that you all can do that in your head, okay? All right, so now that we know our derivative, we're going to use the derivative to help us find the slope of the line. And let's actually, I don't even know where these values came from. They are not the ones I have. So we're going to look at 2, 5, -1, 2, or 0, 1. Okay. And so when we look at those, let's just, we can look at the first one is fine because it's not a 1, 0. So let's look at, we're going to evaluate at x equal to 2, right? So we want to evaluate at x equal to 2. So that's going to give me 3 times 2 squared minus 2. We're evaluating our derivative, right? So that's 3 times 2 squared, which is 4. So that's going to give me 12 minus 2. So that gives me 10. So my slope equals 10. Okay. So now we want to use our point slope equation. So we have y minus y1 equals slope times x minus x1. Well, my point was 2, 5. So this is y minus 5 equals my slope of 10. X minus, my point was 2, 5. So this is x1 is 2. So this is y minus 5 equals 10x minus 20. I can add 5 to both sides, and I get that y is equal to 10x minus 15. So the slope of my line that's tangent to that point, 2, 5, is 10x minus 15. Okay, questions? So for these other ones here, my slope is equal to 1. And my equation is y equals x plus 3. For the second one, my slope is equal to -2. And my equation is y equals -2x plus 1. Okay, questions? Okay. Page 155, number 62 wants us to find the points on the graph at which the tangent line is horizontal to y equals x squared minus 3. Okay. Keep in mind, a horizontal tangent line has a slope equal to 0. Okay. Just think about that. That's this, right? If I had a horizontal line, my rise is 0, my run can be whatever. So I would have 0 rise over run, 0 over 5. My slope is always going to be 5. I mean, always going to be 0, sorry. Okay. So for this one, we first want to find our derivative. Okay. So dy dx is equal to d dx of x squared minus 3. So that is d dx of x squared minus d dx of 3. Okay, so the derivative of x squared is equal to 2x. The derivative of a constant is 0. So my derivative is 2x. Okay, the next thing we want to do is set our derivative equal to 0. Okay, so the first thing we're doing is getting our derivative, right? So this is y prime, our derivative. Our second thing we're doing is set y prime equal to 0 and solve. Okay, so this gives me 0 is equal to 2x, right? So divide both sides by 2, and I get that x is equal to 0. So the horizontal tangent line will occur when x equals 0. Okay, so our tangent, I'm going to put horizontal tangent. At x equal to 0. So now we just need to find the point on the graph where that is so. So we would say y equals 0 squared minus 3, right? Just coming back to the original equation. So I'll plug that in. I'll put that first. So if we say 0, because our x is equal to 0, so 0 squared minus 3, so y equals negative 3. So that occurs at the point 0, negative 3. Okay, question. So this problem was asking us to find the point on the graph where our tangent line is equal to 0. And that occurs at this point, 0, negative 3. Okay, question. So I have one more problem out of this section. This is an application problem. And so for this one, we're looking at a person's temperature during a certain illness. And you could see that the equation is given by this T of T. Okay. And so that is where capital T is the temperature in degrees Fahrenheit and lowercase t is in number of days. Okay. So the first thing we want to do is find the rate of change in a person's temperature. The rate of change, remember, rate of change means derivative. Okay. So first of all, we want to find the derivative. So that's capital T prime because our equation here is T. Capital T, so we just want to find the derivative of that. So that is essentially 2 times negative 0.1. So that's going to be a negative 0.2 t, because then I take -2 minus 1, and that gives me a 1. So that is power of 1 up there. This is 1, so 1 times 1.2, so that's just plus 1.2. And then t, which would be 1 minus 1, so that gives me t to the 0, but anything to the 0 is just 1. And so that would be the derivative of that function up there. Okay, questions on how we got that derivative? Okay, the second part of this wants us to find the temperature at day 1.5 or time 1.5. So we're going to plug this into the temperature. This gives me the temperature. So that's T of 1.5 is what we want to know. So that's going to be negative 0.1 times 1.5 squared plus 1.2 times 1.5 plus 98.6. Okay. So when we simplify that, we get 100.175. So that tells me that the temperature of the ill person after 1.5 days is 100.2 degrees Fahrenheit. Okay. Question. Part C wants to know what is the rate of change at 1.5. So the rate of change, remember, is derivative. So this is, I want to know what the derivative is at 1.5 days. So I have to go to that equation. And so that one is negative 0.2 times 1.5 plus 1.2. And that's going to give me 0.9. And so what this is telling me is that the temperature of the ill person is increasing by 0.9 degrees Fahrenheit per day after 1.5 days of illness. Okay, questions? Right. So let's keep going. Have section 1.6 in the textbook. In this section, we will differentiate using the product rule and the quotient rule. And we'll also use the quotient rule to differentiate average cost, revenue, and profit function. Okay? All right. Any questions before we get started? All right. So our quotient and product rules, we have a couple of theorems to go by, like the previous section. So the first one is the product rule. Okay. So the product rule is basically telling me if I have two functions multiplied by each other, then it's the same as just doing, I'm going to write it out in shorthand because I think it's a little easier to see. So if I have the derivative of FG, right? I want to know the derivative of that. That is equal to, for my product rule, it's equal to my function F times the derivative of my G. So here's F, G prime, plus G, F prime. Okay? So that's all the product rule really is. Okay? So when I see something like this, I always say, hey, let's go ahead and define what is F, what is G, what is F prime, what is G prime, and then we can easily just plug them into this FG prime plus GF prime. Okay? So here, my F function is the first one, so that's x plus x to the 9. My G function is the second one, which is x to the 4. Now my F prime is just 9x to the 8, and my G prime is 4x cubed. Any questions on that so far? So now when I want to do the derivative using the product rule, okay, derivative using the product rule, this is really just FG prime plus GF prime, okay? So that is x to the 9 times 4x cubed plus x to the 4 times 9x to the 8. Okay, any questions so far? So this gives me 4. This is x to the 9 plus 3, right? So that is x to the 12. Plus 9, x to the 4 plus 8, that is also 12. So now, like with my variables in general, this is exactly the same as this, so I can actually add the or the constants in front. So 4 plus 9 is 13, and I have 13x to the 12. Okay, question. So that's the product rule. I want to show you guys the power rule, right? Because that's what we learned in the beginning of last section. And I want to show you that the product rule works for both. So if I had used the power rule, which this one would have been fine to use the power rule on, that's going to give me dy dx is really the derivative of x to the 4 times x to the 9. That is the derivative of x to the 13. So that would give me 13x to the 12. As you can see, we get the exact same solution, whether we use the product rule or the power rule. They're both equally acceptable. The reason we have to learn the product rule is there are going to be instances when we can't simplify something to the power rule, or it can be way more cumbersome and we can't really get to that. So we need to have another technique to solve these problems. And so that's why we introduced the power rule, but we introduce it with a much simpler problem for us to digest and comprehend. Okay? Questions?
For exams, Professor, can we use both? Or, I mean, can we use one each?
Yeah, so for this kind of problem, I would just let you choose which, like, the only problem I'm going to tell you how you have to do it is that one problem using the quotient, the difference quotient. The others, you have to use sound things that we've learned in the course, but with a lot of these problems, you can do them in more than one way, and I'm not going to mandate that they be done in a specific way. The only one that I do require is when I ask you to show me that you understand the quotient difference, because you can't show me that by taking one of the product rule or other shortcuts. Okay, but you would not need to show me both of these on the exam. And truth be told, you probably won't get a problem that is quite this easy on the exam. Okay. All right. So here is another example where maybe this one's not as easy to multiply all of these things together and then just use the power rule, right? Maybe just saying, okay, I'm going to let F equal the first thing and G equal the second thing, right? So my derivative of F, the derivative of 2x is 2, plus the derivative of 5 is 0, so that's just 2. Okay? And the derivative of my G, so 3 times 2 is 6, x, 2 minus 1 is 1. And then for the derivative of this one, I have 1 times -4, and then this gives me x1 minus 1, which is 0, so that doesn't get there. And then the derivative of a constant is 0, so we don't put that up there either. Okay? So using the product rule, I get my f g prime plus g f prime, right? My f function is 2x plus 5. My g prime is 6x minus 4 plus g, 3x squared minus 4x plus 1 times f prime, which is 2. Okay? So let's go ahead and do FOIL to get this problem simplified. We end up with 12x squared minus 8x plus 30x minus 20. Let's distribute this 2 to all 3 pieces here. So that's plus 6x squared minus 8x plus 2. We can simplify this, combining our like terms, we'll end up with 18x squared plus 14x minus 18. Okay, and that's pretty much as low as we can get that, or as in simplest form. So that is the derivative of that given function. Okay. I am going to show you if we had used the power rule, right? If we had used the power rule, first of all, I have this f of x equals 2x plus 5 and 3x squared minus 4x plus 1. That's our given equation. So we're going to do, we have to factor, we have to distribute all of that. It's going to give me 6x cubed minus 8x squared plus 2x plus 15x squared minus 20x plus 5. Okay, so we can simplify this a little bit more, right? Combining any like terms. I have an x squared and an x squared. So that's going to give me 6x cubed plus 7x squared. I have 2x negative 20x, so that's negative 18x, and then the plus 5 out there. Okay, so now I want to take the derivative of that. So let me scoot this up, make it a little bit smaller. Okay, so I want to take the derivative of that. So dx, dy, dx of this 6x cubed plus 7x squared minus 18x plus 5 is going to give me, the derivative of this gives me 3 times 6 is 18x squared plus 7 times 2 is 14 minus 1 off the exponent. So that's going to just give me 14x. 1 times negative 18 is negative 18, and x to the 1 minus 1 is 0, and the derivative of a constant is 0. So you can see here that these two are exactly the same. 2 different methods, one using the power rule, one using the product rule, but they give us the same result. Okay? Question.
You said there's some cases where you won't get the same answer for both. How do you know which one's the right answer?
No, you will get the same answer always because of that. I'm saying there are some cases where it'll be too complex to use the power rule, so you'll want to use the product rule.
Oh, okay, but if we actually did all the steps, we will always get the same answer using both ways. Okay.
Correct. And you'll see as we get through going through the semester, you'll see there are some that you're just like, yeah, it would take me way more work to do the power rule than just to implement the product rule. Okay. All right, so now let's learn a new type, the quotient rule, right? So what if I have one function divided by another function, okay? And just like the product rule, I'm going to shorthand this one, and this would be G, that's a little bright. Let's do G times F prime minus F times G prime divided by G squared, okay? And that's all we need to know for the quotient rule, okay? So here, my F equals X to the 6, my G equals X to the 4. So my F prime is 6X to the 5, and my G prime is 4X cubed. Okay? So now let's just implement here. We have our, so if I want to do Y prime, that equals G F prime minus F G prime divided by G squared. So my G function is X to the 4 times F prime, which is 6X to the 5, minus F, which is X to the 6, times G prime, which is 4X cubed, divided by G squared, which is X to the 4 squared. Okay? So now we can simplify. This gives me X 6 X to the 9 because 4 plus 5 is 9 minus 4 X to the 9 over. So another quick little tidbit about exponents. If I had X cubed and I have that to the 4th power, that's like saying X cubed times X cubed times X cubed times X cubed, or X 3 plus 3 plus 3 plus 3, or you could say it's X 3 4 times, right? So ultimately, this is X to the 12th power. So when I have this X to the 4th raised to the 2nd power, I'm multiplying those two together to give me X to the 8th. Okay? So they're not multiple. When they're multiplied together, we add them. When it's an exponent, we multiply them. Make sense? Any question? All right. So now we can simplify as much as we can. So this gives me, so this here is the quotient rule. Okay. And so we have this, and it gives me 6 minus 4 is 2, X to the 9 over X to the 8. We can use that handy dandy trick to move this up into the numerator. So that's like saying X to the negative 8, right? And so that then gives me 2X as a solution. Because 9 minus 8 is 2. I mean, it's 1. Sorry. Questions? I'm just going to move this up here so I have more room to do the power rule. Okay, so if we had used the power rule, okay, that would have been y equals x to the 6 over x to the 4. We would have brought this up here, and that would have given us x squared. Okay, so the derivative of x squared is equal to 2x. And so you can see this problem would have been a lot easier to use the power rule than the quotient rule. But there are going to be times that we have such, messy functions that we can't easily use the power rule. Okay? Question. All right. So here is another problem. We're not going to use the power rule to solve this one. We're only going to use the quotient rule. And so we have that our f function is the numerator, so that's 3x to the 4 plus 2x. And our g function is the denominator, which is x cubed minus 1. Okay? So we'll do the derivative. So f prime, the derivative, that's 4 times 3 is 12. X 4 minus 1 is 3. Plus 2 times 1 is 2. X to the 1 minus 1 is x to the 0. So that would be a 1. Okay. My g prime is equal to 3x squared, and then that constant, the derivative of constant is 0, so it would just be 3x squared. Any questions on how I picked out the f function, the g function, and then did the derivatives of each?
Yes, could you explain that again?
Yeah. So the derivative, so our f function is our numerator based on the theorem that we had over here. So our f function is in the numerator, our g function is the denominator. And so that's how I picked those pieces out here. Right? So the numerator is our f function, the denominator is our g function. And then we just do the derivative of each of those. So the derivative of 3x to the 4 is 12x cubed. The derivative of 2x is 2. So the derivative of that whole entire function is 12x cubed plus 2. Okay, question.
I have a quick question. How do we got rid of the -1?
Because it's a constant. And when you take the derivative of a constant, it's 0. So that would have been just plus 0. So we didn't need to write it.
Okay, thank you.
Uh-huh. All right. So if I want to know what is the derivative of my function, that is just my g f prime minus f g prime divided by g squared. Okay? So g is x cubed minus 1. F prime is 12x cubed plus 2 minus my f function. F is 3x to the 4 plus 2x. And g prime is 3x squared. All of that divided by my g function, which is x to the cube minus 1, and we square that. Okay? Question. Now all we need to do is using our FOIL, kind of get all of these, and we have to do the -1 here too. Using FOIL and distribution, we end up with negative 12x, not negative, sorry, just 12x cubed. No. X cubed times x cubed is x to the 6 plus 2x cubed minus 12x cubed minus 2. That's the first part. The second one, we're minusing 3x squared times 3x to the 4 is going to give me 9x to the 6 plus 6x cubed. We have to distribute that negative to each of those terms as well. And that is over, I will tell you that my math lab allows you to leave the denominator like that. So if you want to do the math and do x cubed minus 1 times x cubed minus 1, you can, but my math lab will accept leaving the denominator in that form. And so since my math lab does, I also accept it in that form on an exam. Your numerator always has to be simplified though, okay? So this then gives us 12x to the 6 plus 2x cubed minus, actually not, yeah, we'll do that. 2x cubed minus 12x cubed minus 2 minus 9x to the 6 minus 6x cubed all over x cubed minus 1 squared. So now we want to simplify our terms. We can see that for our x to the 6, we have 2 of those. So that gives me 12 minus 9 is positive 3. So 3x to the 6. My x cubed, and I have a positive x cubed, a negative x cubed, 12x cubed, and a negative 6x cubed. So that's going to give me a total of negative 16x cubed. And then lastly, I have just this one constant of negative 2. Okay, all of that over x cubed minus 1 squared. Okay. And if you're curious, that expands out to x to the 6 minus 2x cubed plus 1, but either of those are acceptable. Okay. Questions? All right. So let's look at another example where my f function is equal to 1 and my g function equals t plus 2. I will caution you when you're doing work in my math lab, notice this one has a t. A lot of the times we're practicing with x's. And so if you put your answer in as, if it came out to 5t and you put 5x in the system, it's going to say you're wrong. So if you get it wrong and you're pretty sure you got it right, make sure your variable is the correct variable before you scrap it and do it all over again. Okay. All right. So the derivative of a constant is equal to 0. And the derivative of t is going to be 1, and the derivative of 2 is 0. So my derivative of my g function is just 1. Okay. So this one, we have to use our quotient function, our quotient rule. And that is where our derivative of this g function, capital G function, is my g f prime minus f g prime over g squared. So this is going to give me t plus 2 times 0 minus 1 times 1 divided by t plus 2 squared. Okay, So this is going to give me 0 minus 1 over t plus 2 squared, which is negative 1 over t plus 2 squared. Okay, question. All right, so the last bit of information we have tonight is the cost function. So if you think about it in business terms, your profit is equal to your revenue minus your cost, right? So we, like in this class, a lot of the examples that we look at tend to be around this cost, revenue, profit functions, okay? And so basically what this is telling us is if we have the cost function, it's really the cost of producing some number of items, then the average cost of producing them, right? And so that's just saying, if I take the cost divided by the number of items I produce, that's going to give me the average cost. Okay, same with the revenue. If I take the revenue divided by the number of items I sold, then my average revenue per item is my revenue divided by X. And the profit can be done the same. Take the average profit would be my profit divided by the number of items I sold. Okay. So we have a problem down here, a word problem that says Tongue-Tied Sauces, Inc. finds that the revenue in dollars from the sale of X bottles of barbecue sauce is given by this 7.5x to the 0.7. Okay, we want to find the rate at which the average revenue, okay, so it's asking average revenue, will change when 81 bottles of barbecue sauce are produced. Okay, so we have our revenue function. They give us, that's the 7.5x to the 0.7. Okay, and they also gave us 81 bottles produced. Okay, my average revenue is going to be my revenue divided by my number of bottles I sold. So that is the 7.5x to the 0.7 over the number of bottles I sold, which is 81. Or not 80. Oh, we don't want to do it right now. We just want to do X amount of bottles right now because we will plug the 81 into our derivative because it wanted to know at the rate of change, not how much it was at just the revenue of 81. Okay. So for this is the same as I could move this up here where it's X to the negative 1, right? Or I could have moved this down here where I end up with 7.5 over X to the 0.3, right? Because I have 1 minus 0.7 and gives me to the 0.3, okay? And we'll do it this way so that we can practice the quotient rule a little more. If we had moved it up into the denominator, we would have got the same answer, but it probably would have been a little less complicated. But I am going to do it as the quotient rule just so we get a little bit more practice with that. So my f function is the 7.5. My g function is x to the 0.3. So my derivative of a constant is 0, and my derivative of x to the 0.3 is going to be 0.3x to the negative 0.7, because that's 0.3 minus 1, right? Okay, question. Okay. So I'm going to just move this up here so I have a little bit more room. So my derivative then is going to be my G times F prime minus F times G prime. Okay, divided by my G squared. Okay, and this is going to simplify to 0 minus 2.25 x to the negative 0.7 divided by x to the 0.6, because 0.2 times 2 gives us the 0.6. Okay. And lastly, we can move this into the denominator so that we make our exponents positive. And this is going to equal negative 2.25 over x to the 1.3. So 0.6 plus 0.7 is 1.3. Then we want to take that and we want to evaluate that at 81 bottles. Okay, so that's negative 2.25 over 81 bottles at raised to the 1.3. And that's going to give us a negative 0.00743 so on and along ways. And so basically it says that what this tells me is that when 81 bottles of barbecue sauce have been produced, the average revenue is changing at a rate of negative $0.0074 per bottle. So in this case, you could see producing 81 bottles is probably not ideal because now your revenue is negative, right? You're going to start losing money. So companies will use things like this to help them price match or price point. Where's the best way to price things? You know, supply and demand, right? If I produce too many of these things, then people, then there's so much supply out there that it exceeds the demand. So then it all changes the price comparison. And so, you know, there are actual economics classes that are calculus based, right? And so economists would probably really look at something like this, but companies can benefit from it as well to help them find the equilibrium point where they should price things and things of that nature. Okay. All right. Do you guys have any questions on that? All right. If you guys don't have any questions, that is all of the material that I have for you this evening. Couple of admin notes, just make sure that you go in and take the academic integrity quiz. That helps you get, make sure that you are good to go with the lockdown browser. Don't forget you have a homework assignment also where you'll need to upload at least 2 pages of your notes in one document to help replicate and practice uploading your exam question home problems for work for being graded. And then the last admin note is that remember next Monday is Labor Day and the college is closed, so we will not have class. So this homework from these 3 sections won't be due until 2 weeks. So they'll be due on the Monday, the 4th, the Monday the 11th, I think. Look at a calendar real quick. Yeah, so these homeworks will be due on September 11th. And then, so, no class next Monday. On the 11th, we will cover sections 7 and 8 and do an exam review. And then your first exam is going to be on September 18th, which is 3 weeks from tonight. Okay? Any questions?
Will we have an exam review that we can do ourselves?
So it's already out there. You guys can go do those problems right now. And then when when the time comes and we are looking at it on the day of, I will give you guys just a heads up, like, here's the types of problems, and I'll give you the answer to those on that class period. And then we'll go over any that you might have questions on.
For when we're taking the actual test, are
And
we
that'll be on
allowed to have like,
Alexis,
I'm
go
sorry,
ahead.
are we allowed to have like a note card with some of these like formulas?
No, there's no notes on the exam. The goal is, like, though, by the time you've done the homeworks, that you've become familiar enough with. So essentially for the first exam, it's being able to use a lot of what we learned today. Okay. But yeah, there's no notes on the exam.
So, Professor,
Yeah.
do we take the exam? Do we take the exam during the class time or?
Yeah, so what I do, because typically, I've started this when I teach on the Zoom classes since COVID started. What I do is the exam will open up on Monday the 18th at midnight. It'll close at 11:59 p.m. and you get to choose the 90-minute window in the day, whatever 90-minute window, but whatever time you start it, you only, like, you have only 90 minutes, right? You can't say, well, I'll work on it 5 minutes now and 20 minutes later. No, it's like 90 consecutive minutes. You open the exam, you work on it for 90 minutes. You then have 15 minutes to submit the work in Canvas, and then you're done for the day. So we don't have class, we don't have lecture on the exam day. So you can choose to take the exam at 7 p.m. The one thing I will suggest is not starting it after 10:30 p.m. because if you start it after 10:30, then you're not going to get the full hour and a half to take the exam because it'll shut you off at midnight. Okay? Questions?
So, Professor, on the exam, so we just see the question on the blockdown browser and we write the answer on the paper and later we upload to the Canvas.
Correct.
Oh, all right.
And then I will download the document that you upload with your exam. I'll download it on my tablet. I'll grade it just as if you turn in a piece of paper to me in a classroom. I'll write on it, everything, save it out with a file name, add graded to it, and put that back into your Canvas so that you can see exactly how you did on each of the problems.
Thank you, Professor.
So
And
there
I-
won't,
So
there
will the
won't
test,
be, oh my
will
gosh.
the,
Yeah, you can
Anna,
go.
Anna, go ahead.
I was just wondering if the test will be graded itself. I'm sorry.
No, that I will be grading the tests. You submit the work and I grade the work. Anna, question?
Yeah, as well as the homework, you're saying something about submitting a work on Canvas. Is this,
Yeah, so if you go in Canvas under the assignments link, there is two things. One where you have to take the lockdown browser. It's academic integrity quiz. The quiz really just says, I'm going to do my own work, but it forces you to make sure you can get into the lockdown browser. That really is what the exercise is about. So basically you download lockdown browser, you go in there, you only have one option, I think, is to choose true. And you get full credit for that homework assignment. The other homework assignment is where you have to take at least 2 pieces of paper, put it in one document. So you can do that by taking the pictures, telling your picture to send it to, like at least I have a Samsung. I can select multiple pictures, click share it to a note, and then save that as a PDF. Or there's plenty, I don't know how iPhones work. I don't have an iPhone. But they probably have something similar. And then, or there are plenty of apps out there where you can turn pictures into PDFs. But I need it to all be in one file, and I need you to name it with the naming convention that it'll show you in the upload and the practice as well, like with your last name, comma, first name, and what it is, because if everybody just puts exam 1, then if everybody puts just exam 1 and I download that, then I don't know whose test belongs to who because they all say exam 1. Okay. All right. And then there was a comment in there in the chat, in case y'all didn't see it, says that you can use Scan Pro for iPhone users and it automatically changes to a PDF. So most phones will allow you to do that. And so that's one way that you can do it. Okay. So I would practice that for the homework. Just take a couple of pictures of your couple of pages of notes that we've taken so far, and then you can do that for those. Okay. Questions?
Professor, so how about the time we upload the document for the exam? Because we have the exam around 90 minutes, right, in the lockdown browser, and after that we need to submit the in the Canvas immediately, or we have the time for scan it, and it take it take more time. Yeah,
I've been doing this since summer of 2020, and I had one student that was able to do it, but just had problems uploading in the 15 minutes allotted. The 15-minute standard is actually what Nova Online uses, and so I'm not going to budge on the 15 minutes. It's actually plenty of time to do it because you just literally take a picture of each of your pages. Even if you had 20 pages of notes, it's just click, 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 take your pictures, hold your finger down, select all the pictures, send it off to on the iPhone, use the Scan Pro, or on a Samsung or an Android, you can just share it with the notes, and then it's there. It's not a long process. Okay. And so you'll have 15 minutes from the time you hit submit on the exam, right? So you get a full 90 minutes on the exam, and then 15 more minutes to upload your document. So it's not like you don't have to cut into your exam time. You have 15 minutes from the time you submit your exam. Okay?
Yes, thank you, Professor.
Any other questions? All right, if you guys don't have any other questions, you are free to go. I'll stick around though, in case somebody has some last minute.
So you
Thank
will
you, Professor.
so you will put a recording. Maybe
Yeah.
I can see the recording for tomorrow, right?
Yeah, it might be tomorrow afternoon. I don't know how long it'll take for Canvas to process the Zoom. But as soon as it is done, if I'm still awake tonight and it's done, I'll make it available. Otherwise, it won't be till I get home from work tomorrow night around 5 or 6.
Yeah, thank you, Professor. Have a good night.
You too.